Hello, hello. Can you hear me well? In the back as well? Great. So, good afternoon, or maybe good time after lunch. Hello, everyone at Efficient Kotlin. At this presentation, I would like to talk a little bit about efficiency on your application and memory usage. So if this is the talk to you, if you want to optimize the performance and memory use of your application, stay with me. If not, I know there is a Jetpack Compose presentation in another room that is probably a more cool and trendy topic right now. So this presentation is based on my book, Effective Kotlin, concretely on the last part, Efficient Kotlin. I think that efficiency is very important, but it is clearly not the first priority. People first think about not having exceptions and making your code scalable and easy to read. But if these conditions are satisfied, then we can start optimizing our applications for efficiency so that it scales up, use less resources, and do not have memory leaks. So let's start with the first part, make it cheap. In this part, I will talk a lot about a common abstraction that we all use every day, and we often do not know its cost. It is the abstraction of object. Object looks like something very cheap. It is very cheap, but even something very cheap costs something, and object costs something as well, because for just even an empty object, you need to give some header that is 8 or 12 bytes on nowadays computers, more often 12. And you need to reference this object that gives us 4 to 8 bytes of reference, And this is very little, but if you compare now the primitive int that takes 4 bytes and the integer that needs 12 bytes for a header, 4 bytes for the rest, it's path to 8 bytes. Okay, it would be 16 anyway. But on the end, the object is 4 times more expensive in terms of memory. But then if you add the reference, then it's 5 or 6 times more expensive to have a reference to an integer than to have a primitive under the hood. OK, those are small things, but 5 or 6 times, this can make a difference in some cases. And we are going to talk about this kind of cases. Also, setting a state. This state can be cheap or not. This can depend. We'll talk about that. And passing the function call. This is another thing that is generally very cheap, but even something very cheap can scale up into a significant cost. So how can we improve those costs? I would like to start with not creating unnecessary objects. There are 3 techniques I would like to present to you. And the first one is that we can use object declaration. This is a very common technique that if we have an object, like in here, empty, that does not have any state, we can make it an object declaration. And this is used widely when we send messages, when we have some tokens, all these kind of elements. Notice that in this case, this is a very common practice. We have a generic type arguments, and we need to make it covariant, that is using out modifier, and then we make object as a subtype of linked list with a nothing type argument to make it work. Nothing is a subtype of everything, so thanks to covariance, linked list of nothing is a subtype of all the linked lists. More about it in the book, or I have also a different presentation about generics. It is used on many levels, for instance, on the standard library, empty list, and empty list of returns and object declaration. Another probably more important technique, especially on backend, but it's used everywhere, is to use cache. So cache is basically when you provide an object with a function, with some kind of factory, instead of creating it every time, you can take it from memory. So common practice, when you need to create an object, when you need to return an object, you check if it is there. If it is not there, you create it. If it is there, you just return it straight away. So it is already implemented on many places, including JVM. This is how cache on JVM looks like. If you ever wondered why integers, small integers are having exactly the same object, it is because JVM has cache for integer object. And it can be implemented in your own applications. This is a very simple implementation of Fibonacci with a cache. So we still use a recursive approach, but thanks to the cache, we'll never need to calculate the same value twice. Of course, this is a very naive approach. It works. You can see that, okay, the first time you ask for a value, it takes longer because you need to load all those values into the cache as well. But the next time you ask for it, it's immediate. But it is a very naive approach because why it's a naive approach? Yeah, memory. We traded our performance problems for potential memory problems. So what's the solution? Basically, the easiest solution is to use some well-implemented cache. There are libraries like Kotlin that I often used, or you can implement your own cache. But if you implement your own cache, I recommend to use some object references. Weak reference is not a good choice because weak reference do not protect this object in any way. It will be garbage collected in the first occasion. A much better option for a object reference for a cache is soft reference. It is still not guaranteeing, but basically in most JVM implementation it works like the way that it is cleaned only if there is such need. If we do not have enough memory for other things, then we are cleaning this cache to leave this memory. So that's if you implement your own cache, but more commonly you can just use some well-implemented cache library. Another technique you need to know about is object lifting. So take a look at this example. I hope you can immediately see what's wrong in here. So in count, we call max function for each element, for each element. So we are calculating this max function as many times as many elements we have in this collection. That does not make any sense. This is something that can be easily lifted outside. But this problem can be also much less visible. So what's wrong with this implementation? What's the problem? And why is that the problem?
You're recreating the same object every time.
Yes, so every time I need the same regex, and this regex is very big and complicated, yeah? So parsing this huge regex is an expensive operation, basically. So we could improve this implementation by lifting this property outside. And like in here, we lifted this property, and now it is reused for all the calls. And what kind of problems we've introduced right now? Sorry?
Slower app start, like this is created.
Stay with me, please. Yes, that was one of the questions I wanted to ask. The problem is, imagine that it's your util file, and you lifted many of such heavy objects. And what happens is that they all need to be initialized when the first function is used. So basically, most common it means slower upstart, but it can be also postponing time into the first usage of any of those functions. This can lead to very, very strange behavior. And what we generally do in such cases is that we make them lazy. So they will be only calculated once, but when they are needed for the first time. Another common problem, another thing that I would like you to know about is that we can optimize many functions with inline modifier. So why do we need such an optimization? Imagine that you have a function for each with a lambda expression that is, called many times for each student. So the thing is that calling a function is some kind of a boundary. It's a very, very cheap boundary, but it's still a boundary. You need to, put your address on the stack. On the stack, you need to, jump into with the execution. Once the function is back, you need to take the address from the stack and go back. You need also to store your local state, etc. So it's a very cheap thing, but still costs something. It's not a problem if this is a single function call, but in here, notice that here we call action, which is also calling a function. So every time we need to jump inside this action and back. And we do that for each element. So if this collection is really, really big, then we need to pass this boundary many, many times. And this, this cost adds up and can be significant if you call lots of lambda expressions. And it is especially visible if you capture some state, because state capturing is not, local state capturing is not supported by JVM, so this needs to be wrapped in another object. And again, we need to access this object every time we want to modify it, and this can, can be a significant cost on the end. So the solution to this problem is that we use an inline. And if you check out the standard library functions, nearly all standard library functions that accept parameters of functional type are inline, primarily because of this problem. What happens if we use inline? During the compilation, the usage is replaced with the body of the function, and the usage of the lambda expression, in this case, a parameter of functional type, is replaced with the body of this lambda expression. And that's why we use inline modifier, but only primarily for functions with parameters of functional types. It is not needed for other functions, except for a few cases. One big advantage of this inline modifier is it makes it possible to make reified type arguments. And what it means is that when we are having a type parameter, like in here, t, when normally we cannot reference its class. Why? Because these types are gone during the compilation, because JVM does not have deep generics. It is, they were introduced in version 5. They are not very much in the bytecode. They are all erased during the compilation. But if we make this function inline, then we can make it reified, and everything is perfectly fine. So we can write functions like this one, something that was not possible in Java. Because during the compilation, the function call is replaced with its body. Of course, inline modifier has its costs, so we need to mention that as well. Inline functions cannot be recursive. Clearly, we would infinitively inline. They cannot use elements with more restricted visibility. Again, clear, if we would inject their body into the place that cannot see it, then it wouldn't work. And this is the biggest problem. And the third one, it's a very tiny problem, but sometimes it is considered that it can make our code grow. OK, the next item is connected to a story. A story from US, where NASA wanted to send a Mars orbiter. This was a time of space explorations, and government was pushing a lot of money into that. So this was a huge and very important project. During this project, one part of this orbiter was developed by external company. And there seems to be some misunderstanding between the NASA and this other company, because the physical orbiter expected its control software to operate on Newton seconds, when the software produced and expected everything in pound for seconds. It's a more British kind of unit of measure. It's hard to talk if you are speaking in two other languages. And with this simple mistake, the Mars orbiter just crashed into atmosphere once the control software started working, and the whole project was burned. And with this project, over $300 million were burned. And this kind of problem is one of the problems we are dealing with nearly every day, as we are still, dealing with many units of measure in our applications. And we often need to indicate those units of measures. Imagine the following timer where we set time. It is very easy to, incorrectly understand what this time means. So some people introduce in their name what's the unit of measure, time millis. That is helpful to some degree. Okay, it's convenient to use that, but still someone could make a mistake, like in here. Someone makes a mistake. You can think that decide about time does not indicate its result unit of measure. This is fed into this timer, and it's hard to even tell what's the unit of measure of decide about time. And let's say that decide about time returns, let's say, seconds, and again, it will be woken up way too early. So how can we improve that? A common practice that is very, very popular in the company I work for, in Allegro, is to wrap those types with classes, minutes, millis, and then the typing system will help us here. We will not make this mistake anymore. Although we are, again, traded this time safety problems with performance problems. You need to wrap those objects, keep those wrappers, etc. So this is not ideal. And here comes Kotlin 1.3 with its back then new feature, right now still experimental but not new anymore. That is called inline classes. In the Kotlin 1.5, these inline classes were changed into JVM inline value classes, so you might, use a new notation if you use a newer version of Kotlin. I decided to keep the old one, but in the new version of the book, there is the new notation already. And what it means that a class is inline, it means that during the compilation, the class will vanish. So this class needs to wrap over one value so that during the compilation, it is replaced with this one value. So you might ask, but what happens to its methods? And the answer is that all the methods are inline as well. I mean, not inline if you do not give them inline modifier, but they are becoming static functions that accept the wrapped types in this. The wrapped types. So this solution can solve our problem. Although you need to know that it only protects us if we use direct classes instead of interfaces, because if you would give them an interface time and accept time, then we couldn't use an explicit value. I would like to also add that this same feature is useful for other cases for type misuse. So in here, we have a student ID, teacher ID, and school ID that are all integers, so they can be easily misused. And they need to be integers because our entity expects that, our database expects them to be an int. But if we make them inline classes, then compiler first replaces this student ID, teacher ID, and school ID with integer, and then the classes are generated, so both database is satisfied and we are safe. The next thing I would like you to know about is, or maybe technique you'd need to know about, is that we should eliminate obsolete object references. Think of it this way. You probably know this guy. You work with him every day. This is our garbage collector, and we kind of trust garbage collector that it well cleans our unused objects. And we do not need to think about memory references and memory problems. And this is perfectly fine. This works this way, unless we, are cheating him, unless we are giving him some problems. Because from time to time, if we steal reference to an object that is not useful anymore, we kind of pretend it is useful, and we create something called a memory leak. So memory leak reference to an object that is not useful anymore, but is blocking this object from being cleaned. And these memory leaks can be obvious. This is, I hope, something that is clear, clear to all Android developers. That is, if you should not assign a reference to an activity into some companion object property, because then it will be referenced statically, and so it cannot be garbage collected. But this can also be hidden in some way. Imagine the following situation. I do not keep a reference to the activity, but I keep a reference to some function in here. But the problem is that this function, you can see it captures a reference to the activity. Because it uses this, it means it captures a reference to the activity. And so our whole activity will be referenced there as well. So here is another example of the same problem. Here you have an implementation of lazy. You know lazy from the standard library. It's a delegate. And in this lazy, you are passing some initializer. And if this property is not initialized, you use this initializer to create a value. So what's the problem here? The problem is that we are keeping the reference to the initializer. That is a function. And if it is the function, it can keep whatever it captures. So it can capture basically anything, maybe some activity, maybe some fragment, whatever. You see? It's always such problem if you keep a reference to a function. It is also a common problem if you keep some generic reference. And so the simple solution to this problem, the simple optimization for this problem would be to clear this initializer once it is not needed anymore. So once it is not needed, I set null there, and the function can be garbage collected. Of course, if you do that, then you do not need to have is initialize indicator, because it is initialized once the initializer is null. Okay, the second part of this presentation is dedicated to efficient collection processing. So collection processing is something like that. This is how we used to process collections in Java with some for loops, ifs, and collections sort. In Kotlin, in Java 8, and also in Kotlin, there were some essential improvements introduced, like functions like map, filter, sorted by descending, etc., that let us simplify this collection processing. And thanks to that, it can be, nice, readable, and pleasant for the readers. Although even though it is already quite good this way, we still need to know a few techniques how to improve collection processing. And I will start with the difference between iterable and sequence. Those two are very similar. If you take a look at their interfaces, they are practically identical, and no wonder people are, misunderstanding both of them. The difference between those two. So the thing is that iterable represents, iterable represents something that you can iterate over, but iterable represents something that is there, that is eager, that is always ready to be used. When sequence basically represents something that is lazy, that is cold, that is created on demand. By the way, the same is the difference between iterable and sequence as between channel and flow, if you learn about coroutines. So, if you filter or map any kind of iterable, you always create a new collection that is ready to be used. You see, there is constructor used, array list, and in filter too, this constructor is populated with data. This object is populated with data. So filter does all the operations. When sequence filter is only making a decorator over the previous sequence. So it is doing no operations here. It is only decorating sequence with new capabilities. And thanks to that, it is lazy. So when you process a sequence, everything that is in the middle, like map and filter, are intermediate operations. They do absolutely nothing. They just add another operation to the sequence. And everything happens on the last terminal operation. And what are the consequences of this? So first of all, when you compare processing iterable and sequence, first of all, collections have different order. So you first filter all the elements, then you map all the elements, and then you for each all the elements. In sequence, you go element by element. So you first filter the first element, map first element for each first element. Filter second element, it's done. Filter third element, map third element for each third element, etc., etc. This might not look big, but you can see that this can be much better optimized. It is also more natural. Lazy is also more natural, so there is a lot of space for low-level optimizations in this area as well. But the first big difference is that if you do not need all intermediate elements, then lazy sequences will be faster. Clearly, if you finish your processing with find, then sequence will do the minimal number of operations. If you operate on an iterable, you will always map all the elements first. So this is the first big difference. The second is that sequences can be infinite. So we can make infinite sequence builder. This is not a very commonly used trait, but it is, it is used on different kind of katas or algorithmic challenges. But in practice, I don't see it very often in use. Nevertheless, it is possible only for sequences, never for iterables. Another thing is more essential. It is that sequences do not create intermediate collections. Iterable always create a new collection that it populates with data. This is not a problem if you have a small object, but this is a problem if you have really, really big objects. I will show it in a moment. That is why we consider sequences better for big or heavy operations, for collections. I would like to show you concrete examples. This is Chicago crimes. Chicago, if you ever want to find a nice source of data for some analysis, Chicago publishes all the records of all its crimes for 2001. So 20 years of crime in Chicago, it's a lot of data. And you can play with that with sequences, like first read lines, then drop something, split it by commas to reach the concrete column, and then find the crimes that included cannabis in its tags. And you count how many of them there were in Chicago since 2001. If you start that on a computer like this one, I'm pretty sure it will throw out of memory exception. Because this file, it's crimes in Chicago. It's like few gigabytes of data. Drop this amount of gigabytes of data because it creates another collection and populates it with all the data. Map a little bit less, filter not much less. And just in the last line, we are, cumulating that in a single value. But it is a very different story if you use a sequence. If you want to use a sequence, you use lines. You might wonder, why do we have this lambda expression here? It is because sequence does not need to iterate over the whole file, but it needs to know when to close this file. So the rule is, outside of this lambda expression, it closes the file. Because otherwise, you could just iterate over half of the file and forget about that. So for the sake of safety, this is how use lines is implemented. And this is much more efficient. It will give you a proper result. So I suggest to use sequence for big collections, big in terms of memory use, or in terms of the number of operations. That means tens of thousands of operations, not hundreds of operations, with more than one processing step. And to make it clear, I'm not pro this suggestion that was in Kotlin some time ago, and it was very controversial to always convert into sequence. No, I do not suggest that. Only in some particular cases. For a simple collections, it will be even faster to operate on an iterable. And definitely easier, because you do not need to go into sequence and back from sequence into collection. This is a new item. So if you read this book, if you read it on Amazon or on ebook, you will find it. But on this one, you will not. This is something I discovered on backend since for the last 2 years, I'm primarily working on backend. And this is something I haven't used in Android at all, but it is very useful on backend where we operate on big collections that we need to hold for some time. So imagine that you have some list of configurations that you read from some file, and you need to often access it by name. The most intuitive way to do that is to keep them as a list and find this configuration by name. But finding this every time requires iterating over a list of configurations, and so O(n) operations. More concretely, size of the list divided by 2 on average. So how can we do it better? Very simple solution. We associate by name what transforms this list into a map from the name into the configuration. Notice that you need to have unique names, or otherwise some of those elements will be lost. Yeah? And once you have it, you can find a configuration by name immediately. O(1), it's like finding an element by key on a map. It's immediate. So this is a really nice optimization. Another thing that I have learned is that instead of using group by is a useful operation for more complicated collection processing. So for instance, if you need to count the number of users in each city, you have a list of users. You can group those users by city, and then map values into size. That's a nice way to count how many users you have in each city. So what group by returns is a map. So it's map of a list. So it is a mapping from a city to a list of users in this city. So this is convenient, this is nice, this is something that we use quite often in more complicated collection processings in both backend and frontend, I believe. But the only problem is that this group by creates intermediate map, and what is even more problematic, it creates as many collections as there are keys. So it's not a big cost, but it could be better. So how can it be better? It can be improved if we use grouping by. So grouping by is just a simple wrapper over a list, and all the magic happens on the next operation, like each count or reduce. So here are the same solutions, the same problems solved with grouping by and its methods. Operating grouping by is more demanding because it has less functions than a map. But if you want to optimize some of your collection processings, you can try to use grouping by instead of group by. The I believe, pre-last item in here, I make a reference to what I started with. You remember I said that integer is, the wrap type is 5 or 6 times more expensive than int, the primitive. That's of course not a problem if you have a single integer, but if you have a list of integers, then you could optimize it by using an array of primitives. And in Kotlin, we use an array of primitives with functions like array, int array of, long array of, etc., etc. You can also transform a list into an array of primitives. This is not a suggestion for all of you. Please do not do that in a small startup applications. But this is a suggestion for library creators in here, especially if this library creation involves some data science or graphic processing. Then, having an array that is 5 times smaller and is significantly faster in terms of processing can make you a difference. But clearly, operating on array is harder than operating on lists, so do not do that in simple applications. And the last item, that's also a reference, because the first item of the book is to prefer immutable elements, to prefer immutability over mutability. And the last current item of the book is to consider using mutable collections, because in terms of performance, mutable collections are faster than read-only collections. Using read-only collections creates a copy with every time you use it. Creating mutable collections does not. And here is a map from the standard library using mutable collection. Fun fact, if you consider that mutable collection array list can be upcasted into read-only collection list. This is how Kotlin is constructed. That's everything I got from you today. That was all based on the book, Effective Kotlin. I typed you, and sorry, the person who is currently looking at the phone, stay with me. And I would like to let you know that it's all described in the chapters 7 and 8. Both those chapters are currently, all those items are currently available for free as articles on KT Academy. It's my website, so if you want to read more about that, you can find everything for free over there. I am from Allegro. I had some references to the code on Allegro. It's I don't know if if this is good to say, but it is. It's like a huge shop, something like Amazon, but in Poland, and in my opinion, a really well designed project with really great developers inside. My company is KT Academy. I conduct workshops and I teach Kotlin. That's everything from my side. That was Effective Kotlin. Thank you for your attention.